Hi, my name is Christopher Hull, and my presentation on independent and dependent variables is based on the plastic bottle crisis. And this issue is important to us because plastic bottles harm wildlife, and we want to keep our planet clean for our future and for our future generations. And here are a couple of facts about how plastic bottles harm wildlife. More than 8 million tons of plastic are dumped into our oceans every year, and all known species of sea turtle, 54% of all marine mammal species, and 56% of all seabird species have been affected by entanglement or ingestion of marine debris. This includes an estimated 58% of seals and sea lions, plus whales, dolphins, porpoises, and manatees. And this is a picture of a river in Russia where there is a lot of trash, primarily plastic bottles, floating down the riverway. And it's just an example of why we need to keep our earth clean. And now the problem I would like for us to focus on in this presentation is about plastic waste, more specifically plastic bottles. And I have a fact here. It's actually a quote from an article on Forbes. Two statistics jump out immediately. One, that globally humans buy 1 million plastic bottles per minute. The second, 91% of all plastic is not recycled. On top of that, it is estimated that over 500 billion plastic bottles will be sold in 2020. And this brings a theme to the presentation. The problem that I think math can help us solve is how can we reduce our plastic waste? And now we come to our example. On a typical day at school, Jane consumes and disposes 2 plastic bottles of water. They are convenient for her busy schedule. And now, out of this example, we want to identify the independent and dependent variables. And now with the independent variable being the number of days Jane is at school, and the dependent variable being the number of plastic bottles of water Jane consumes and throws away, we want to represent this in a T-chart, graph, and an equation. And here we'll start with our T-chart, with X representing the number of school days that Jane consumes water, and Y being the number of bottles of water that Jane consumes in a school day. And the equation is correlated with the X and the Y. So the equation shows that the number of bottles of water is equal to the number of school days multiplied by 2 because she drinks 2 bottles of water each school day. And that's how we come up with the numbers in our T-chart. And so when we plot this on the coordinate plane, you can see our line goes up exponentially, actually. You can see that Jane consumes many bottles of water over the course of 1 school week and 2 school weeks. And now, to sum up the presentation, we want to discuss the underlying problem discovered by math in this presentation, which is basically the independent variable. Jane consumes a lot of water on school days. She uses the disposable bottles for convenience, and so a possible solution would be using a reusable bottle during her school days, so she won't have to dispose of so many. She could keep it in her backpack and refill it at convenient times of the day for her, which could be in the morning before her first class and at lunch at the end of her lunch period, so it lasts her the remainder of the day. And this concludes my presentation. I thank you all for watching, And I hope that this brought about some thought about how math can help solve real world problems.